This is an overview of the iotaWave architecture. At the heart we have the iotaWave server. This is an application written in Java with a MySQL persistent database. The iotaWave server is accessed via client software. The iotaWave client. The iotaWave client is written largely in JavaScript, and it runs on a standard browser. Standard meaning Firefox 3, IE 7, Chrome, never IE 6. The iotaWave client talks to the iotaWave server. The client has an outgoing queue written in JavaScript. The server has an incoming queue. The processes, the operations generated on the client are sent from the outgoing queue to the incoming queue. These events are queued considering two basic thoughts. Some operations, document operations, relate to the editing of documents themselves. These need to be queued and delivered one after another. An operation destined for the server before a second operation must arrive there first. There are other operations, which one could call non-doc ops, which are not order critical in the order in which they arrive. For example, pulling up menu screens and that sort of thing in the client itself. The server processes any incoming operations and puts them onto an outgoing queue for delivery back to the client. The client to server maintains XHR long polling mechanism. The XHR long polling mechanism maintains an open connection between client and server, ideally at all times, but being the internet, sometimes we lose that connection, which is why we have an outgoing queue. A response to a request from the client is only sent back to the client when a connection actually exists here. iotaWave, as other wave servers, is designed for federation, meaning that we could have other iotaWave servers sat here, and these need to communicate with each other. We have outlined a protocol that we use for this, called the Real-Time Federated Document Protocol. This is designed to be fast and efficient and allow processes to communicate between two servers, passing messages back and forth. Now, the most important aspect of the iotaWave architecture is how we listen for federated messages from other servers. This is done by the server listening on two ports, although these ports are configurable in the setup files. We listen on port 80 for requests that come in from the client to the server, and we listen on port 25, the standard SMTP port, for incoming messages, for the RFDP incoming messages on port 25, port 80 for the client to the server. We listen on port 25 because iotaWave has a built-in SMTP client and server. It is important, very important to us, that if the wave technology is going to be taken up by the market, specifically by the business market, we have to build upon the back of email. Email comes in on port 25. So all incoming email, which may come from mail servers which are out there, will come in on 25. Therefore, the RFDP protocol is in essence an extension of SMTP. We bring in incoming emails which come into the iotaWave server, and we also bring in federated messages which come in on port 25. Port 25 means that we don't need any new DNS entries apart from the MX records which already exist for a server. Additionally, the iotaWave server can pull in POP3 messages by a POP3 connection to a POP server. The email does not have to come in to the iotaWave server itself. At the present moment in time, there is no established protocol for wave-based servers, communication, real-time servers to talk to each other. Therefore, RFDP has designed to be encompassing and extensible. So hopefully, as other vendors with their other wave-type products see the need to federate with each other, as ultimately it must come, RFDP has been designed so that we can accommodate other users, other vendors' methods of federation, and maybe even other vendors can pick up on RFDP. But for the moment, it's important that we're able to federate between different iotaWave servers.